Hi, my name is Lisa Richter. I'm the Director of Industry Outreach and Growth for CSIA. Welcome to the Masterclass. Before we get started, a quick word about CSIA. Probably most of you here today are familiar with the association, but if you are not, all you really need to know is that CSIA's mission is to help SIs build better businesses. How do we do that? Well, for starters, we have a team of volunteer SIs who have crowdsourced a best practices manual to help SIs scale their businesses. In fact, the BP committee regularly reviews and updates the manual, and it's currently on its sixth edition with plans to get started for the next version very shortly. For those companies that want to take the best practices to the next level, CSA also offers a certification program that includes a third party audit. Many companies find that this audit is extremely helpful for them to deeply understand their businesses and scale. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are not currently a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events and other resources from accounting to sales to operations to training 365 days per year. It also means that you and your team can attend the CSIA conference because this annual in person event is members only. Registration is still open, and if you are registered, the conference app is now available for download. You should have received an email with instructions on how to access it. The app platform is called Huva. In case it landed in your spam folder, you might check for that. If you want to just get a flavor of CSIA and its members, I encourage you to listen to the Talking Industrial Automation podcast. CSIA members talk all things industrial automation, and it's just a great way to hear what your peers are up to. A couple of housekeeping notes before I turn it over to today's speakers. If you have any questions during the presentation, please use the Q&A feature in Zoom. That helps us stay organized. I also ask that you please turn off any automatic note-taking applications. Those are currently against CSI's policy, and I appreciate you understanding. That being said, the session is being recorded, and you will get a link to the recording in the next day or so. At this time, I would like to turn it over to today's speakers. Hal, take it away.
Thank you, Lisa. Welcome to CSIA Masterclass. My name is Hal Chastro with Graybar Electric. I'm the National Director of Industrial Automation. Graybar is an employee-owned company, and we have over 290 locations across the U.S., Canada, and Puerto Rico. Over 75 automation specialists to help assist you in your design and support of your applications. And we represent the best-in-class manufacturers such as Schneider Electric, Phoenix Contact, Hirschmann, and SMC. Basically, we are local all over. And so now I'd like to introduce our speaker, Eric Tengens, our national market manager for Graybar Electric and our wireless solutions expert at Graybar Electric. He's responsible for our strategy and working with the wireless ecosystem to bring best-in-class wireless solutions to Graybar's customers. He has over 25 years of experience in the wireless market through work with cellular carriers, system integrators, and distribution, providing solutions to end users, contractors, and carriers. He's a frequent speaker at industrial events and works with organizations like IWCE, WIA, OnGo Alliance, NATE, and Safer Building Coalition to understand the issues facing building owners, influence codes, and help develop an understanding of the business drivers behind the solutions. So, Eric, take it away, buddy.
All right. Well, thank you, Hal. Welcome everyone. As he said, I'm Eric Tenges. I run Graybar's wireless business, and I work with our sales teams and our customers to specify best-in-class wireless networks. So on the webinar today, we're going to explore how private cellular networks extend our connectivity options beyond wired Ethernet and Wi-Fi in support of industrial automation. I'm going to address both technical and business perspectives, which is really a crucial combination to get this done. Now, look, as industrial customers look to improve productivity, reliability, efficiency through automation, sensing, control solutions, the networks which enable this are critical to their operations. So a quick review of the agenda, and I will tell you, we could easily talk about this subject for several hours. We don't have that much time, so we won't be. So we'll stay pretty high level in order to cover the main points and leave some time for Q&A at the end. So obviously, we'll do a little bit of an introduction here in terms of the connectivity challenges that all of you are probably facing in industrial automation. We'll talk through a few use cases. I'll give an overview of what a private cellular network looks like from an architecture standpoint. And then probably most importantly, and we'll spend a little time on this, is kind of a performance comparison between both wired, Wi-Fi, and cellular. I'll show you what the difference is in density of the infrastructure between Wi-Fi and a private cellular network. Again, we'll talk about how we make the business case, because if we can't do that, we're not going to get anywhere with this. Everybody always wants to know about device availability. A little bit of is what are the skills I'm going to need in order to go be successful in this, and where can I get them? And then we'll move on from there into the Q&A. So let's jump right into the content. So as I kind of mentioned before, industrial automation is being challenged by the demands of mobility. More and more things are unable to be connected by wires. And so we've got to have a mobile or wireless network to handle those things. We've got harsh environments. We're putting an increasing number of devices into that environment. So we've got to be able to handle those large numbers. And of course, maybe most importantly, the security expectations are really, really high. And so how do we deal with that? So if you look at your traditional options that you're used to utilizing, the wired Ethernet, Wi-Fi, and even public cellular, particularly in outdoor or remote locations where you might have to resort to that, they often fall short. So in the reliability that you can get from that, I wouldn't say that about the wired Ethernet. By the way, that's going to be your most reliable connection always. Determinism, mobility, the reconfiguration of spaces is a big one. The coverage and the control that you can get out of that network, all important elements. So we're going to talk here about how we can take these private cellular networks and use them as a practical alternative, but also as a complement. So I'm not necessarily saying that everybody's going to go tear out their Wi-Fi. I think all these networks have a place in this environment. But as you add this capability with private cellular networks, it's going to create new opportunities for you to grow your business and really make it easier to sell the automation and control. As I've talked with Hal and his team a number of times, when you're out there trying to sell the automation control, if you've got gaps in what you're able to provide, or your customer has gaps in the network availability, it's really hard to sell that automation and control without a way to connect it. So let's talk about a few of the use cases. And first of all, what is it you want to be looking for in a use case? I often talk to organizations about what is it that is preventing you from connecting equipment to monitor, control it. You know, what is that shortfall? Or even what is connected already, but falls short of the full potential of that connectivity. So it's not really living up to what you were trying to do. You're going to have things, particularly in Wi-Fi, we'll talk about that, where you've got limitations in terms of the amount of coverage you can achieve, particularly over larger distances outdoors. The reliability in terms of latency. Latency is really important when it comes to control and automation. There's interference issues that you run into as you put more and more wireless access points in, and of course security levels. So those Wi-Fi limitations impact your project. That's certainly really anything you're trying to connect to that point. But in particular, anything that's mobile or motion, AGVs that are moving across, large sites, those are very, very difficult to achieve with Wi-Fi. Typically brownfield sites, and this is not to ignore greenfield, of course, as well. But you get a lot of situations where in brownfield where recabling is really it's gonna cost a lot to put in cable. It might not be practical. It's difficult, and in particular, it's probably disruptive. Nobody wants downtime, and if you have to have downtime in order to bring in cabling, that takes time, and that costs a lot of money just in that downtime alone to start running cables in those places. So if we can move into a wireless environment where I don't have to disrupt at all, that's a big advantage. So you can see other things on the screen that we'll talk about more, but telemetry, digital twins, video, augmented reality, of course, integration with your PLCs, sensors, SCADA, DCS, and OT networks. And I mentioned a couple of times, and we'll go in deeper into it, outdoor connectivity is a real challenge because of the reach of Wi-Fi. So let's talk a little bit about the network itself. So as I mentioned, this is really an emerging connectivity option. So, your customers may or may not be familiar or have heard of this option before. So you may be introducing it to them. Of course, if they've gone to some conferences, it has been, particularly at industrial conferences, this has been a big topic of conversation. So you may have heard a little bit about this already. And so you may run into customers that are very curious about how to integrate this into their overall plan. So a private cellular network can certainly operate in licensed or owned spectrum, and some customers, particularly government or tribes or some other elements, may have some spectrum that could be utilized for this. But for the most part, we're going to be talking about the 3.5 gigahertz spectrum known as CBRS. This is a spectrum that's been allocated by the FCC for free use for everyone, but it is controlled. So as you can see on here, it requires connection to the radio itself. This is not providing any kind of internet connectivity or a gap in the system, but the radio itself requires a connection to something called a SAS, or spectrum allocation system. And this eliminates any kind of interference between you and any kind of adjacent users in the same spectrum. So unlike Wi-Fi, which I like to kind of call a free-for-all, right? Everybody can use it at all times, but there's the limits then become on power. In this case, we don't have the same power limitations because we have that control by the SAS. So what we can do in this then is provide a much more reliable, secure, and more in control type of network by having the on-premise and owned infrastructure by your customer, or maybe it's managed or hosted by yourself, depending on what the needs of that customer is. It's a very scalable type of solution. We can get into thousands and thousands of devices and provide really, really nice bandwidth. Many of your applications may not need that kind of bandwidth. Most of the deployments today are using 4G or LTE cellular technology that you're certainly used to already. But we have 5G available as well if we need lower latency, especially, or greater bandwidth, then we might move to a 5G network. And as you can see on there, again, we talk about LTE and 5G or 4G, 5G. These are well-established technologies. So while the ability to do this is new, only in the last 5 or 6 years has this spectrum been available. And the license spectrum is very expensive, so it's been a kind of a blockade against doing this in any kind of cost-effective manner. But with this access to the free spectrum now, we can take very well-established technology that's been out there for years in commercial networks and now apply it in the private enterprise. And all of this, of course, then helps us lead to a kind of a tangible ROI if we can impact uptime and efficiency, which I think you guys are all very familiar with. That's what a lot of your solutions do. We want to enable those in more and more places so that you can create that ROI. You can see there's multiple layers to the network. We've got an infrastructure layer, which, indoors we're using small cells that look an awful lot like a Wi-Fi access point that I'm sure you've all seen. Outdoors, I know I've got a picture of a tower there. It could be a tower. It's more than likely going to sit on a rooftop or a pole. We don't have to get up to, hundreds of feet or anything like that. Not that we can't, we certainly could. But for outdoors, we're going to mount something up relatively high. There's a control layer, which really involves the network core. This is what controls the radios and creates the interface between the radio network and the IT network. It's controlled by the SAS, as I mentioned to you before. And then we have the option of this being connected to the internet through the cloud. Doesn't have to be, and we'll talk about that a little bit more later. And then, of course, we have a device layer. What are the different things we can connect to a network like this? And I've got some examples on there, but we'll talk about this a little bit more later on. I do want to mention the core itself can be hosted. So you might host this yourself at your own premise. You might have a managed service provider that you work with that's providing that core network as a managed service. I think more likely in the industrial applications where we need that ultimate control and security, we're going to take that core and put it on premise. Okay, so let's talk a little bit about the security and policy piece of this. So this architecture you're looking at here shows how a private 4G or 5G network connects to an enterprise-style policy layer, the authentication and IP management system. So every device is securely identified, controlled, and authorized before accessing enterprise resources. As I mentioned before, the security level that is required these days to avoid all kinds of bad actors and different things from getting access to this are super, super important. So we can now take, and this has been something that we haven't been able to do in the past, but now we can integrate cellular technology into the IT fabric of an enterprise. So we can meet required policies, essentially meshing the cellular with the IT world. And this was holding back deployment, besides all the problems with access to spectrum and other things like that. But it was holding back deployment for Fortune 500 industrial companies due to their security policies. So at a high level, what we're looking at here is how user devices connect over either a 4G or 5G radio network. They pass through the mobile core, and then they're governed by policy, authentication, and IP control services before reaching the enterprise data resources. So, the outcome for the enterprise data plane is that once policy and authentication are applied, traffic flows through the core user plane function. Devices are granted controlled access to enterprise applications, OT systems, and IT networks. So that the access is policy driven, secure, and centrally managed. And this is really, really a crucial part of this. And again, we could probably go on for hours talking about the architecture, but we're going to move on. So I want to really talk a lot about the comparison and performance between these various networks that you're all utilizing. And we could talk a long time on this slide, and you'll have access to all of this in the recording, and we can share slides afterwards if you would like as well. So we'll focus on a few things that I have bolded here. One of them, and a really important one, is latency. And I'm sure you're familiar with wired Ethernet's going to always give you the best and most reliable latency. But again, you may not be able to connect everything via wire. So while you can get less than 1 millisecond of latency in a wired network, in Wi-Fi, you're typically looking at 10 to 50 milliseconds. I've seen a lot worse than that, by the way. And it tends to have a high variance level, which makes it not reliable when you've got to have that low latency. So certainly when you talk about controls, you need low latency. When you talk about anything in motion, you need low latency. You don't want to wait to adjust how something's traveling and have it run into someone or something. Commercial cellular, kind of similar. You've got more latency built in there because you're kind of tromboning data back and forth to someone that's off somewhere else. When you look at private cellular, we can, in an LTE or 4G network, get into that 10 to 30 milliseconds range very reliably. 5G, we can get it down as low as 5 milliseconds, and I've seen even better than that. So we can get down there close to what the wired Ethernet can provide in that latency. Let's talk next, and this is a big one, is the transmit power. So of course, it's not applicable in Ethernet, but industrial Wi-Fi. So I mentioned earlier that Wi-Fi is kind of a free-for-all. So what the FCC does with Wi-Fi is they control your output power to a very low level, a maximum of 1 watt of radiating power. And they do that in order to try to mitigate potential interference. And I'm sure wherever you're sitting right now, if you opened up your cell phone and looked at your Wi-Fi networks, you see a whole bunch of different Wi-Fi networks. And those Wi-Fi networks are all competing for the same spectrum, the same resources. Think of it as a multi-lane highway with a traffic jam. The more users, the more networks you see on there, they're all competing for the same space, right? And so they are interfering with each other, even at a low power level. But that low power level has other impacts we'll talk about on the coverage side. Commercial cellular certainly has a much higher transmit power, but your user equipment is still relatively low power. So what you can transmit back to that network. But the private cellular, while my user equipment is that same power level as the commercial cellular, my indoor AP, I can do anywhere from 1 to 5 watts. So a 5-watt transmit power, that's 5 times what you're going to get out of a Wi-Fi access point. And actually, I've seen situations where outdoor access points are being utilized, or outdoor small cells being utilized indoors. And those are in the 5 to 20 watt range. So we're pushing a lot more power through this system, which allows us to cover a lot more area, which has a lot of advantages. So as you look at the coverage radius, of course, with wired Ethernet, well, you're stuck with a wire. So as I mentioned, if you're in motion, you can only get so far. That's not practical for lots of things. And running wires in some places is not practical, or they're going to get cut or disruptive or what have you. When you look at your industrial Wi-Fi access points, and look, this says 100 to 300 feet, but I'll tell you, you put a Wi-Fi access point on a 40-foot ceiling in a warehouse. By the time you get down to the floor level, there's not a whole lot of power left. So even that 100 to 300 feet is a very generous number, and what creates the problems with trying to cover large spaces, which I'm certain that all of you are dealing with. Commercial cellular, they have kind of the maximum power because they're the only user within their spectrum, so they're getting up to as much as 5 miles or more, although lots of those networks are tuned to be a lot less space as they're trying to increase capacity. When you look at our private cellular networks, my indoor access points are going to go anywhere from 300 to 1,000 feet or more, so way more than what we're going to get out of a Wi-Fi access point. And outdoor, while I can't do the same power that AT&T or Verizon broadcasts at, I'm getting a pretty good chunk of that, and I'm going to easily do, with rough terrain, a half a mile. With a little bit easier terrain, I might get as much as 2 miles or more, which is probably more than anybody on here needs in most situations. But I've seen people do things along rail lines and things like that where I'm going to point it, and if I can get 2 miles each direction, I'm covering a 4-mile swath from one transmitter. So we're talking about drastically different coverage radiuses than what you have through Wi-Fi. If you look at the density then in say 100,000 square feet, I show in Wi-Fi 6 to 12 access points or more. I'm going to tell you right now, nobody's doing that few. It is way more than that's used to cover 100,000 square feet. And again, you've probably all seen that. In my example for indoors on the private cellular, you can see I might cover that space of 1 to 3 access points. I'll show you an example with quite a few more than that, and only because in a lot of situations there's a desire for more redundancy in case I have to take an access point offline or such. I want the area still to be covered, so you may have some overlapping coverage, which is totally fine. Now, mobility and roaming. This is a big one here. So wired Ethernet, clearly there's no roaming. You're stuck wherever that wire ends up at, right? Maybe you're off a little bit of a service loop, but that's all you're getting out of the wired Ethernet. When it comes to Wi-Fi technology is not designed to hand off from one access point to the next. In other words, you have to drop service from one access point to move to another one, reestablish contact, and go on. And thus, anything in motion, you're going to disconnect, reconnect, right? It's not meant for mobility. It's meant for fixed location wireless is really what Wi-Fi is designed for. And that causes a lot of limitations on what you might be able to do with those kind of networks. Certainly, commercial cellular, we're all familiar with driving down the highway at 70 miles an hour on a cell phone call, hopefully hands-free, and we move from one cell tower to the next without ever noticing any difference, right? And that's because cellular technology is specifically designed for mobility and handoffs, right? So as we move that into our private cellular network, we have the same exact thing. We can hand off completely seamlessly in motion without any disconnect and reconnect, and that has a ton of advantages for what you're trying to do. So the last one I want to talk about is security. So certainly wired Ethernet, you're most secure. It's physical. Somebody has to intercept the wire in order to get into that, unless they find another back way into the network. Your Wi-Fi, we kind of refer to it as kind of a medium level of security. But in a lot of cases, if you've got the SSID and the passcode, you're in. Right? That could be pretty weak. And when you look at a lot of hacking incidents that have happened, almost always they're breaking their way in through the Wi-Fi. So it's definitely a point of vulnerability that for things that need to be more secure, and I think a lot of what you're doing has that need. Um, it's not sufficient. When you look at security on a commercial cellular network, it's pretty good actually, but it's in control of the carrier, and your data is traveling back and forth to the carrier. And for a lot of people, that's just not going to cut it for a level of security. But in a private cellular network, this is enterprise-owned infrastructure, and especially if you put the core on the premise. And I can even have a fully sovereign network, meaning that I don't have any connection to the internet whatsoever. This will operate as an internal data network. You have that option, or of course it could be. So you can create a very secure network, without all the interference and so forth. So again, we could spend a lot more time on this, but I wanted to point out some of the major points here. Now, I want to give you a little bit of a typical warehouse looks like when you deploy this type of network. Okay, so density of the deployment, and this is very approximate here. This is not meant to show real life here necessarily, but give you an idea of what we're talking about. In this warehouse, you can see on the left-hand side a Wi-Fi deployment. It's going to have access points scattered all over the place. And the reality is that as the organization over time, they find coverage holes, and they will find coverage holes. And you will in industrial environments, in warehouse, and any other places. Everybody's always finding coverage holes, and so they keep putting more and more dots on the map here, adding more and more access points. Well, I got a hole over here. Great, stick another access point in there. This is what happens all the time. I've also, as you look at the outside part, and this is a warehouse, I'm showing access points at each of the truck bays. This is very common as well. You need them both covered indoor and outdoor for both the approach and inside. I didn't show them on both sides, but this drastically increases the AP count as you try to put all those out there, because again, the very short reach of the Wi-Fi access points, I'm putting a ton of them outdoors. And then you've got outdoor areas. What I'm kind of trying to show here is, say, a lay down yard that's, call it 100 feet or more away from the building. In order to get an access point out there, you see my little red lines. Now I'm laying fiber out. I might have to trench a parking lot, which is disruptive and expensive to do just to try to get Wi-Fi out there. So a lot of times there's just no service out there whatsoever because of the challenge doing it. Now, if you look on the right with the private cellular, because I've got so much more power, and again, this isn't meant to be what you would see in a design, but I could cover that 75,000 square feet very easily with 2 access points. Again, and I'll show you another next example where we're going to use more than that, but I could cover that space with no coverage holes whatsoever. That takes dozens and dozens of Wi-Fi access points with only 2. And then I'm showing 1 outdoors. I put that up on the roof, and I'm going to cover all those truck bays, lay down yard, and probably a mile away if you want to from that one point. So we're talking about a lot different types of density here. So of course that density drives cost and your total cost of ownership. So this is a very, very conservative estimate. But if you look at 100,000 square feet, I'm going to have at least 6 to 12. The reality of that is dozens more than that. But that's what I'm looking at in Wi-Fi APs, which then causes a whole lot of cabling and conduit, a lot of mounting locations, a lot of power, a lot of RF design effort, a long time commissioning and optimizing the system, the ongoing tuning, so the maintenance of that because of all the access points. It's a constant battle. You've got lots and lots of points of failure, and your expansion cost, well, it's kind of linear. If I want to open up a new area, I'm going to stack in a whole bunch more APs. Again, on the private cellular, I could do that with 1 or 2 access points. So my cabling conduit, not much. Mounting and power, very few locations, not that much power utilized. The design effort is really, really low. The amount of time to commission it, get it done real quickly. I don't have to do much tuning and optimization of this thing because it's a very simply designed system. I've only got a couple of points of failure. My expansion cost, I might not, I say minimal, it might be nothing, as those access points can cover more than what they have. So again, I may do more than those one or two in order to have overlapping coverage to provide redundancy, eliminate downtime, things like that. So of course, everybody's going to want to know what does it cost in comparison here. So here's a real life example of a 75,000 square foot warehouse where the Wi-Fi access points were mounted anywhere from 23 to 35 feet. And keep in mind that the actual ceiling is at 40 feet. So why are they down at 35 feet? As I mentioned to you before, because of the low power, by the time that signal reaches the floor, I've lost a whole lot of that signal. So what am I doing? I'm mounting these things on down rods in order to get them closer to the floor. So what happens with those down rods and the access points sitting at 35 feet? Well, that might be close to the top of a rack in the warehouse. And now my picker trucks are hitting the APs and destroying them, causing me more maintenance problems. All right. On the private LTE side, I can put them all the way up at the 40 feet, or better still, I may put them on a sidewall at only 20 feet, facing inwards, kind of pointing down the racks essentially. Because I've got so much more power, I can just push that signal all the way across the entire warehouse. Now that's a lot easier to maintain and access if I need to. I don't have to disrupt operations by getting a lift truck out in the middle of the warehouse, and now I can't access that aisle while I'm messing with it on the sidewall. I can do all that, and operations keep on going. All right, my power requirements are and receive signal strength are going to be actually lower in order to keep that high-speed connectivity with an LTE network versus the Wi-Fi. You can see this example in the cost example. They had 39 access points, so a lot more than that 6 to 12 I mentioned before. 39 and 75,000 square feet. Now, again, they wanted a lot of redundancy in this case, so actually used 9 different private cellular access points. But you can see in the cost differential, almost half the cost of all those access points to put in all that hardware and software. And of course, your installation cost with all that stuff, all the cabling and installation labor or what have you, in this case about 50 grand versus 10. Both applications, you're supporting their main application here was to support barcode scanners, but you can see your difference in cost, half the cost. Now, look, there's a lot of different things I can do to move that number on the private LTE side down. I can move it up. I'm highly unlikely to move it higher than the cost of a Wi-Fi network. So as we've talked about all these advantages to a private cellular network versus a Wi-Fi network, I can do it probably for less the cost, or at the very least, at a same cost. And this is important because, in brownfield sites, you may be having to deal with a budget cycle or a technology upgrade cycle. And they've already let's say they've got that $130,000 budgeted for the Wi-Fi network. If you can come in and say, hey, I'm gonna give you a better network, we're gonna connect more things and have better service on those for same or less money, they don't have to rebudget. They've already got the money ready to go in order to implement a network like this. All right, so let's talk a little bit more about making the business case. So I've got some data here from some surveys from some big outlets that I think are important here. So the first one here deals with ROI, and that's Ericsson. They're a big cellular radio manufacturer. They did a logistics case study in 2024 where they were able to document a 20% productivity gain and 15% lower capital expenditure. So not quite the 50% I showed on the last slide. Then again, Ericsson kind of sits at the top of the market, so they're a little bit more expensive system. So not surprised that they're showing, but still a 15% lower capital expenditure compared to Wi-Fi. So even an expensive system, again, I'm going to either be similar or less cost and pull those productivity gains as a result of deploying that network. Downtime is a huge issue, of course, right? It's a huge expense. So the more sensors, monitoring, and controls, all those things you're out there trying to sell that you can deploy at a customer, the more we can mitigate downtime. So providing a network that enables this, obviously really, really interesting. So you can see that the unplanned downtime today averages about $14,000 a minute across any types of organization side. That's a high cost of downtime. $14,000 every minute of downtime. Again, you're probably familiar with this kind of data. You probably use that as you're trying to sell automation and control. You can see that over 90% of enterprises reported hourly downtime costs exceeding 300,000, and 40% of those exceeding $1 million an hour. Right. So if you look at this as the cost for global 2,000 companies, they're losing $400 billion a year, or roughly 9% of their profits to downtime. So this is a huge financial reason, part of that business case. And again, you're probably, again, familiar and comfortable with making that kind of argument just based on the solutions that you're selling already. And again, the point here is that we're going to enable more of those solutions to go in and to operate at their full potential. So one last piece here, ABI Research looked at manufacturers who have already deployed private 5G networks, and they're showing up to 30% productivity improvements, 25 to 30% reduction in maintenance cost, and more than a 40% decrease in workplace accidents. So what we've enabled here with that private cellular network is, again, more of the solutions that you sell. And when you can do that, you have these kinds of improvements. So I can't tell you enough is making them to different people in the organizations, but you need to be able to make both of those cases to your customers. All right, so I'm going to talk just a little bit about wireless network quality. We've kind of addressed this. This is a little bit more of a summary here, but the reality of Wi-Fi is a very, very dense array of access points. You've got interference as they interfere with each other and other networks that might be adjacent. You've got all kinds of roaming issues. You have coverage holes. As our VP, Graybar's VP of IT says, and because we operate a lot of warehouses, he's always chasing ghosts, right? That they're moving around. As the stock on the shelves moves around, the holes move around. So he's always chasing it, trying to add more access points. And you've got very noisy and metallic types of environments. When you look at private cellular, I have far fewer access points. I'm dealing in a managed spectrum where there's no interference. I've got higher power, so I can drive uniform coverage and push it farther. And those networks are built for roaming. If you look at most industrial sites today, and again, this is probably something you've seen, very few are achieving reliable wireless everywhere. And that holds back your ability to provide those solutions since the customer doesn't have a network that can actually handle them. For you as an integrator, you can design for the environment. I mentioned to you before, I'm not trying to replace Wi-Fi. That may certainly happen in certain situations. This is really more of an all-of-the-above strategy. So we're going to have hybrid architectures that involve, wired Ethernet, Wi-Fi, and private cellular, right? So I'm going to use the Ethernet anywhere I can. No doubt about it. It's going to be the most reliable, lowest latency as we showed that. It just has so many limitations in where you can do it and anything in motion. Wi-Fi is going to be for things that are not mission critical applications. And private cellular, I'm going to use that for things that you wish you could connect with Ethernet, but you can't. Right? I mean, that's kind of the bottom line there. All right, everybody always wants to know, what is it can I actually connect into these networks? And the reality is virtually everything. Anything that operates on IP, right? So on the left-hand side, what you're looking at here are the types of things, more than likely, I'm going to be connecting with an Ethernet gateway. And you can see one, it's a Multitech one down here, which is really an industrial quality gateway. It can handle the harsh environments. It can go outdoors. I might still put it in an enclosure if I'm putting it outdoors or in a super harsh environment. But this is a very durable gateway. So I'm going to use that to provide an Ethernet output that I can connect to my PLCs. I may put it on board on an AGV or forklift. I may use it to connect surveillance cameras. I didn't talk about surveillance much, but industrial sites, again, security is important. A lot of times my security and surveillance is outside looking in. and I might want to have some inside or outside looking. I'm sorry, it's it's inside looking out, and I might want it to be outside looking in. That means I need to put cameras out at the perimeter, and I don't really have the time, the cost, budget in order to run fiber out to all those locations on the perimeter. But if I have a wireless network outside, I can connect my cameras. So while most of them are going to need a gateway, there are some that have a CBRS radio native in the device. From what I've heard, and I couldn't tell you specific ones, but some of the PLCs are starting to include CBRS capability in them as well. So we may be able to connect some of that stuff directly. But realistically, sensors, your handheld interfaces, robots, whatever, all these things, I'm going to connect with a gateway that's going to provide me a very reliable connection. Now, what can I directly connect to a CBRS network? These are things that are going to have a SIM or eSIM chip already in them. So barcode scanner devices, the largest 3 barcode scanner manufacturers all have a CBRS radio included inside their scanners today, and many others are including them as well. So scanning's a really easy, really easy application to drive onto these networks. Most tablets and smartphones, they also, for years now, they've had the CBRS chipset in them, including some really ruggedized devices meant for industrial types of settings. And there's even two-way radios. So you look at old two-way radio systems that are in a lot of these industrial settings, we can move them to a private cellular network now. So again, you should not look at the device side as a limitation. We're going to put some pretty inexpensive gateway. More and more things as we go through time are going to have this built into them, as all of you put in more of these networks down the line. Not at all dissimilar from what we experienced as Wi-Fi came onto the market, where initially everything had to have a gateway or dongle or what have you, and over time now everything has Wi-Fi built into it. That's where we're headed on these types of networks, and there's already quite a few things. All right, so the big question is, what am I going to need to know and be able to do in order to deploy one of these? Because you're probably saying right now, Eric, I've never deployed a cellular network before. I don't know what I'm doing. This RF stuff looks like a lot of voodoo to me. I don't know. And probably a lot of you are working in some RF types of connectivity in these environments already, but this may not necessarily be in your wheelhouse. So what do you need? Well, I've got to be able to do RF spectrum planning, coverage modeling, network design, interference and signal testing. I need to understand the rules around using CBRS. I got to be able to commission a network. These are probably not things that you're familiar with doing. However, and you may or may not have the IP networking and architecture experience to deal with VLANs and routing, segmentation, and integrating IT and OT. Well, hopefully you've done a little bit on the IT/OT integration piece already. Security side, who's managing all these SIMs, authentication, segmentation, zero trust, single sign-on. I could read all of these to you. A sovereign network if there's no cloud. Then there's the management of the core network, so understanding the core concepts in LTE and 5G, how to drive quality of service for particular applications, monitoring. Now, you probably do have these skills here, and this is important because I'll tell you right now, the RF integrators out there, they don't know anything about industrial integration, PLC, SCADA, gateway protocols, all those kind of things. So there are definitely parts that you guys play a very important role in this. So how do I fill these gaps? All right, so I already kind of told you what those typical gaps are. I think you know what your strengths are, and this is where Graybar comes in to help you to do this. All right, so let's say that you want to be a little bit more hands-off. You're not going to run all this stuff. What we can do is pair you with the RF integrators who are very, very skilled at these types of things. So you work together with them in order to both propose and deliver and maintain this type of network for your customer. And we work with all the best integrators across the country. We've got a very healthy wireless business. And so we can pair you with people that know what they're doing. If you want to be a little bit more hands-on and have a little bit more control, maybe you want to, be able to sub contract technical services. Graybar actually offers through a very large engineering company a la carte technical services. So you can pick the parts that you need and buy those and not buy the others that you don't need. And along those lines, this may evolve over time. So we've got access to training both from manufacturers or engineering companies, what have you, to gain training over time as you decide that you want to learn more about this and be able to self-perform different functions. And again, those technical services, we can overlay those on top of your capabilities as they evolve. We can certainly hook you up with contractors that are expert in IT networking if you don't have that piece of it. We're going to help you with the vendor choice and support. We've got all the best, best in class manufacturers. They provide that with proven products. We even have some pre-built solution bundles to make it easier for you. And of course, we handle the support escalation and supply chain logistics that you just expect from a distributor. So we can look at your individual situation, the skills you have, the gaps you have, and what you look to evolve over time and build that solution for you to make sure that you can go out there and do these types of things successfully right from day one. All right, quick summary, and then we're going to get to Q&A. So again, private cellular, it's extending your connectivity and your capability well beyond Wi-Fi. Hopefully, I've made that case multiple times over that this is a lot more capable type of network. We've got much more reliability, better security, especially due to the SIM chips or eSIM that requires a device level authentication. So I'll compare this. You have a Verizon phone. You can go buy a Verizon phone. You could power it up and you could see their signal. All right, no different here. You could see the signal. I can't do anything with it until Verizon on the back end activates my phone. Same thing here. You can have a device that's capable of receiving a signal like this, but until on the back end an IT and their organization activates and authenticates, allows that device to be on the network, it's not going to be able to do anything. So that's a really important part here in terms of the security. I've got better performance, lower latency variance, fewer access points, large coverage area, and again, mobility. These are really key points. I've got a cost benefit as I reduce the amount of infrastructure and complexity and disruption, which means I've got a lower total cost of ownership. These types of networks are ideal for mobility, for brownfield, outdoor, huge application in outdoor spaces, safety critical use space. And maybe most important to all of you is that you as integrators, this creates new tools to help you meet challenging requirements. Again, what is it that you would connect? Where would you deploy your solutions, but you haven't been able to due to a network that just doesn't support it? So with that, I'm going to move on to our Q&A session. And we'll push back to Hal because I haven't been watching. Do we have any questions yet in the chat? And if we don't, by the way, please feel free to put questions in the chat and we'll try to address them as best we can.
So one of the questions came about why not just fix the existing Wi-Fi?
Why don't I just fix? Well, sure. And everybody's trying that every single day. I talked about before about chasing ghosts, adding more access points, trying to get rid of those coverage gaps. The reality is the technology isn't built to do the types of things. When you say fix, I mean, probably a little more specificity about what we might be trying to fix. There's a whole lot of different things. I can't fix the latency. It's what's inherent in the technology. I can't use higher power to create a better coverage area because the FCC says I can't, right? I mean, so there's only so much you can do with the Wi-Fi, and everybody, because that's all they've had to this point, that's what they've been trying to do, is trying to fix the Wi-Fi. But the reality is that it falls short.
And industrial devices, are they limited for private cellular?
Yeah, so I kind of showed a slide before. Your limitation really is your ability to carry, mount a gateway device that's going to provide Ethernet output. That's really your only limitation. Again, there are devices today, particularly barcode scanners and different types of scanners that have the capability built into them. Most everything else for right now, you're going to be working with a gateway. So as long as something is IP based, can take an Ethernet input, which I think is probably most of what you guys are doing, there's not a limitation. Just as long as there's a location we can mount a small gateway that then plugs into the Ethernet port, we're good to go.
So that's how you'll handle the older barcode scanners. What about newer barcode scanners? Is there new technologies for those that allow us to use the wireless or the?
Yes. Yeah. So again, all the major makers, I'll kind of steer away from mentioning names here, but we could do that offline if anybody wants to. But they're building in a CBRS radio, so they're handling that 3.5 gigahertz, and they are operating directly off of that network, and that's in use in lots of locations all over the country today. So yeah, the newer scanners over the last couple of years, they've been integrating this capability into them. And so that should not be a limitation. Somebody's got older scanners, they might be using a Bluetooth connection, and so maybe you've got Wi-Fi that's on a picker truck or something like that. I could operate that Wi-Fi and have it front-hauled off of the private cellular network, or I can replace that with a cellular gateway like I talked about, and then you're using that Bluetooth connection from the truck to the scanner itself if you've got older scanners.
So I knew this is a kind of a new topic in respect to using it with the industrial automation. Is the private truly good enough for control?
So look, there's a lot of opinions on this, and I think I mentioned earlier that if I have a choice, it's there and it works, I'm going to use my wired Ethernet. That is going to be your best solution for control. There's no doubt about it. But there may be a lot of things that you want to control that you haven't been able to control because it's not practical, cost effective, or even possible to get a wire to the thing that you want to control. And so this is your next best option to control. So is it good enough for control? Yeah, I think it is good enough for control, especially if the other option is not controlling, right? So let's provide more control on things. Particularly I think where this is going to rear its head the most is in big outdoor environments that are really difficult. But it could even be an indoor in places that where you're going to be doing frequent reconfigurations of the space. I've seen in greenfield applications where they put hundreds and hundreds and hundreds of cable drops in a building in order to try to deal with all the possible places the equipment might go somewhere in the future. That's really expensive. It's a lot of wire, takes a lot of time. So it may be, Hal, what I do is I've got my private cellular network on the control side where I've got a cable, and my private cellular network is my redundant connection. So for some reason I have experience a cable cut or an outage or whatever it is, I've got this as my backup, and it's going to be a darn good solution for that.
Awesome. That's all the questions I see in the Q&A, buddy.
All right. Well, we can, Lisa, we want to give it another minute or two in case people want to type in some more questions. One thing I'll tell you is, again, we had to go through this really quickly to fit this in the time constraints. And you see my contact information here up on the screen, and Hal, I think you probably put it in the chat as well, so people can cut and paste. Yeah. So I am very happy to have a follow-up conversation with you, talk about your specific situation, maybe your specific customers or challenges that you're facing, and engage in any way needed. We've also got regional subject matter experts across the country in Graybar who can engage at a local level. And for the right opportunity, Hal, I travel a lot. I'll get on a plane and we'll go engage directly with you and your customers and go and help them figure all this stuff out.
I just wanted to point out there was a little bit of chatter in the chat about Wi-Fi security and the number of industrial wireless integrators out there. It was more commentary though, just to ping that for you. Okay, so I guess we're winding things up here, and my colleague is going to put up one. Oh, we got a last minute here. It says, what's the max distance between endpoints?
The max distance, well, that's going to depend a lot on obstructions, terrain, what have you. Obstructions indoor, obstructions outdoors. Trees have an impact on how far I can go. Certainly, rough terrain. If I've got a hill or ravine to deal with, that's going to cut down on the amount. If I had a perfect unobstructed flat view outdoors, nothing else to deal with, I'm going to easily cover a couple of miles. I think I mentioned a rail line. So you're going down a train track that might be perfectly straight and flat. I could very easily get that 2 miles, maybe even more. Some of that might depend on how high on a tower I can mount. So I put a little bit higher tower, I'm going to have a more direct line of sight and cover more distance. But I would say pretty reliably, up to 2 miles. And beyond that, we got to get into a lot of specifics to determine, what might be in the way of our signal. But a far cry from anything you're talking about on Wi-Fi. You try to do that same thing on a train track with Wi-Fi, and you're going to put a lot of money into that, trying to cover that. And again, your train's moving, so it's going to keep losing connection, having to regain connection. If it's going fast enough, by the time it loses connection with the other one, it's already past the next access point, right? It doesn't work.
Yeah. So good thing your contact information is in the chat, because if anybody wants the slides, I encourage you to contact Eric or Hal. They'd be happy to send you over those slides, and you can work with them on that. All right, so a few last comments. I just want to say thank you to our speakers, Eric and Hal, for this informative discussion, and to encourage you to bookmark the CSIA events calendar so you don't miss any upcoming events. And that's a wrap. Once again, thank you for joining us, and have a great day.
Thank you.